starting with number 21, we're going the opposite direction. Now we want to condense the given expression into just a single log expression. So in 21, we're given the log base 5 of x squared minus 25 minus the log base 5 of x minus 5. So a subtraction of logs we can turn into a division. So this would be the same as the log base 5 of x squared minus 25 over x minus 5. But now what we have here in the parentheses can be simplified a little bit. This is a difference of two squares, which factors as x plus 5 times x minus 5, which means we can cancel this factor of x minus 5 in the numerator with the x minus 5 that we have in the denominator, which just leaves us with this x plus 5 inside the parentheses. So we have log base 5 of x plus 5, and that would be our simplified answer. Number 25, we have the natural log of 3 plus the natural log of p minus 2 times the natural log of q. So I'm going to start by pulling this 2 up. Instead of a coefficient, I'm going to make it an exponent. So that'll look like the natural log of 3 plus the natural log of p minus the natural log of q squared. And then an addition of logs we can turn into a multiplication, and a subtraction of logs we can turn into a division. So that's going to give us the natural log of, we'll have the 3 and the p multiplied together in the numerator, and then the q squared, since it comes after a subtraction, is going to go in the denominator. So we have the natural log of 3p over q squared. Number 29, we have 3 times the natural log of the cube root of z squared minus the natural log of xy. So a subtraction we can turn into a division. So this would be the same as 3 times the natural log of the cube root of z squared over xy in the denominator. And then this 3 we can pull up as an exponent. So the natural log of the cube root of z squared all over xy raised to the third power. But now remember, the cube root of z squared, that would be the same as having an exponent of 2/3 and then when you raise an exponent to another exponent, you multiply. So 2/3 times 3 would give us just 2. So we just have a z squared in the numerator, and then we need to distribute this exponent to every factor that's inside the parentheses. So we would also have an exponent of 3 on the x and an exponent of 3 on the y. And then that would be the most we could do with that expression.